So at this point you might be asking yourself or wondering why we need to know how to factor, why we need to know how to solve quadratic equations, what this has to do with anything, where does this come up in the real world, right? So it's a very typical question, and it's a good question, right? It's one that's a lot of people ask in these math classes where you do all sorts of weird sort of, I hate to say abstract, but abstract kind of stuff that doesn't seem to relate to anything. Well, now we're going to learn at least some of why we need to know how to factor and how to solve quadratic equations, right? And this is really just skimming the surface. There's a lot of applications. We could practically fill an entire course in uses for solving quadratic equations and other types of equations. So we're not going to do that. We're just going to look at a few of these applications. And in fact, we're going to do four main types. The first one, barely an application, but these are just what I like to call number puzzles. So they're little puzzles that ask you to figure out numbers, right? Second, somewhat more useful, has to do with rectangles. You know what rectangles are, but there's a lot of things that are rectangles. If you have a piece of paper in front of you, it's in the shape of a rectangle, right? If you're watching this on screen, it's in the shape of a rectangle, right? Anyway, so lots of rectangles that we'll get into, a couple of those. The third will be triangles, in particular right triangles. And something you may have forgotten by now. The Pythagorean Theorem applies to right triangles. So we'll look at the Pythagorean Theorem again. And lastly, these are projectiles. Projectiles are things that you either throw or you drop. So dropping and throwing, if you want to call it that. Right, and how long it takes to drop something or to throw something. All right, so those are the four main applications we're going to solve, and we'll do maybe a couple of each. Okay, so let's start with the number puzzles, and they go like this. Okay, so the first example, find two consecutive even numbers whose product is 168. Okay, so that's the question. So we're looking for what? We're looking for two numbers. And in fact, they're two even numbers. So you know what even numbers are, right? 2, 4, 6, 8, 10, and so on. Right? And they're consecutive even numbers, right? So it's not 4 and 10. Those aren't consecutive, right? Consecutive means one right after the other. So like 6 and 8 are consecutive. But the product of those, 6 times 8, is 48. So it's not 168, right? So those aren't the answers, right? Now, I mean, we're just guessing, right? It's not 8 and 10, because 8 times 10 is 80, and it's not 168. So you get the idea, right? We can keep going. Maybe we'll get there eventually. Or we can do this more systematically, right? So first thing to look at is, let's just label these two numbers, right? So let x be the first number, so the first even number. And we could say let y be the next even number. But we can do better than that, because the next consecutive even number, how do you go to the next number, right? The next even number. What comes after 10? Well, 12, right? How do I get 12? You just add 2, right? Right. What comes after 4? 6. If you add 2, you get 6. So the next consecutive even number is x plus 2. So that's the second even number. Okay. Yes. Now, if we're not talking about even numbers, if we're just talking about consecutive numbers, then you would only add 1. Right? The next consecutive number after 12, right, is not 14, it's 13. The next consecutive even number would be 14. Right? Okay, so x is the first even number, x plus 2 is the second even number. Those are the two numbers. How do we find them? Well, what do we know about these two numbers, right? Their product is 168. So let's write out the product. The product means you multiply. X times x plus 2. That product has to be 168. Right? Well, look at that. This gives us an equation. Right? This gives us an equation for x, and now we just have to solve that equation. So x times x plus 2 equals 168. All right, and in fact, this is a quadratic equation. If we multiply this out, x times x is x squared, plus 2 times x is 2x, and that equals 168. However, right, we know this is not in standard form because it doesn't equal 0. So to put it in standard form, let's just subtract the 168 from both sides. And now we're left with x squared plus 2x minus 168 equals 0. Okay, now it's in standard form. Right, so the next step, of course, is to factor. Right, so what two numbers, right, have a product of negative 168 and a sum of positive 2? Well, if it's obvious, great. If not, let's go through the whole list here. So it's not going to be negative 1 and 168 because when you add up those, you get 167, not 2. If you divide by negative 2, I think you get 84. And negative 2 plus 84 is 82, but that's not equal to 2. So if we divide by 3, we get 56. And that's not it either. 53. If we divide by negative 4, we're going to get 42. And 42 minus 4 is, 38, which is not 2. We can skip negative 5, right? It's not divisible by negative 5. But negative 6, for whatever reason, I think it's 27? No, hang on. It's 28. Okay, I was off by 1. Okay, well, 28 minus 6 is 22, but that's still not 2. Right? What about 7? 168 divided by 7. Oh, yep, 24. And 24 minus 7, 17, which is still not 2. All right, moving on. Can we divide by negative 8? I think we get 21. Just checking. And 21 minus 8 is 13, so that still doesn't work. Can we divide by negative 9? Nope, not evenly. 10? Nope. What about 11? Nope. What about 12? Oops, sorry. Or negative 12, and we get 14, right? So negative 12 times 14 is indeed negative 168, and negative 12 plus 14 is indeed 2. So there's our match. So the two numbers are negative 12 and positive 14. Okay. All right, so that's the factoring part. All right. Now we just have to solve, right? Because it does equal 0. And that's pretty easy. X minus 12 equals 0, x plus 14 equals 0, so we get x equals 12, or x equals negative 14. So wait a minute, so there's two answers here? Well, it depends on what you mean by consecutive even numbers. Usually I guess we don't think of negative numbers as being even, but they can be. So yeah, there's actually two sets of answers here, right? If x is 12, remember that was our, going back here, that was our first number. The next number would be x plus 2. Well, x plus 2 is 12 plus 2, which is 14. So 12 and 14 are two consecutive even numbers, and 12 times 14 is 168. So that works. Now let's look at negative 14. What's the next consecutive number? Consecutive even number. Negative 16? No, that's going the other way. Negative 14 plus 2 is negative 12. So negative 14 times negative 12 is also positive 168. So yeah, negative 14 and negative 12 are also consecutive even numbers whose product is 168. Yeah. Now, if it says consecutive even positive numbers, then we can get rid of the negative 14 and the negative 12. But it didn't say that they had to be positive. So yep, negative 14 and negative 12 also work. All right, so that's the first number puzzle. Let's try another one. Okay, here's the next puzzle. The product of two consecutive positive integers is 32 more than 5 times the smaller number. Find the two numbers. Okay. So the product of two consecutive positive integers. So we're looking for, again, two numbers. And these are consecutive positive numbers, right? Integers. It just means whole numbers, right? They're not going to be fractions here. So let's let x be the smaller number. And then the next number is just x plus 1. Right? Consecutive positive integers. It doesn't say even. It doesn't say odd. Right? So you're not adding 2. You're adding just 1 to get to the next whole number. Right? So x and x plus 1. Right? So if we take the product of those two numbers, and here's the product, x times x plus 1. What do we get? Well, we don't get 32. We get 32 more than. So 32 plus 5 times the smaller number. The smaller number is x. Okay? So again, it's just translating these words into this equation. So just read it carefully and write down exactly what it says in terms of x and x plus 1, right? Okay, so the next step, of course, is to solve this equation. And it is a quadratic equation, although it doesn't look like it. If you multiply this out, right, x times x is x squared. X times 1 is x. And that's going to equal 32 plus 5x. So, right, standard form, we have to get 0 on the right side here. So let's take away the 5x from both sides. And that leaves us with x squared minus 4x equals 32. Now we can take away the 32 from both sides. And that leaves us with x squared minus 4x minus 32 equals 0. Okay, so we just have to factor x squared minus 4x minus 32. Right. What two numbers have a product of negative 32 and a sum of negative 4? So let's start with the usual negative 1 and 32. That adds to 31, which is not only not negative 4, it's not even negative. So that tells me the bigger number should be negative. Let's try 1 and negative 32. That adds to negative 31. Still wrong. So it's not negative 2 and 16. Right? We can't divide by 3. We can divide by 4 and negative 8. So 4 times negative 8 is negative 32, and 4 minus 8 is negative 4. Yeah, that's it, right? So x plus 4 times x minus 8. Right, we're done factoring. Now we solve. We set x plus 4 equal to 0, and x minus 8 equal to 0, giving us two possible answers, x equals negative 4 and x equals positive 8. Okay, so again, we might get two possible answers here, except in this example, if you go back to the very first question here, it says two consecutive positive integers. Negative 4 is not positive. So we can cross that out because this is not a positive number. Right? The question is only looking for positive numbers. And 8 is positive, so 8 should work. Right? So we can check the equation. Right? Right? X times x plus 1 equals 32 plus 5x. Does x equal 8 work? So 8 times 8 plus 1. Does that equal 32 plus 5 times 8? All right, so 8 times 9 is 72. And 32 plus 40 is also 72. 72 equals 72. So it has to be 8, right? 8 is correct. Right. So the question was to find the two numbers. Right? The other number is not negative 4. We crossed that out. The other number is the larger number, right? It's x plus 1. So if x is 8, x plus 1 would be 9. That's the next consecutive positive number, right? So the two numbers are 8 and 9. All right. So those are number puzzles. And they're just not going to get any more difficult than this. The main thing you have to remember, though, is right when you say consecutive numbers, that's just x and x plus 1. If they say consecutive even numbers, right, or odd numbers, then it's x and x plus 2. Right? So consecutive even numbers, consecutive odd numbers, you got to add 2 to get to the next consecutive even or odd number, right? But if it just says consecutive numbers, that's just, the next number, 1, 2, 3, and so on. Just add 1. All right, so I hope that helps. Okay, so here's the next type of problem. This has to do with rectangles, right? In fact, it's right there in the question. We have a rectangular garden. Has an area of 117 square yards. The length of the garden is 4 yards longer than its width. So we have to find the length and width of the garden. Okay, so rectangular garden, let's look at it from the sky. Looking from above, it might look something like this, right? It's a rectangle of sorts. And of course we know that this is the length of the garden, and this is the width of the garden, right? And we know the length is longer than the width, so that's the way I drew it. And then the area, in other words, what's inside the garden here. So highlight that. Oops. Sorry about that. I didn't close off my rectangle here. There we go. I hope that does it. Yep. Slightly darker color here. There we go. So the area inside the garden here, right, is 117 square yards, if I can abbreviate, square yards. Right. So hopefully you remember how to find the area of a rectangle. Well, if you don't, I'll tell you right now. To find the area, you just multiply the length times the width. Right. Area of a rectangle is length times width. Right. Or if you're looking at it from the side, it's the length times the height. Right. If this is the height, right. But in this case, it's length times width. Right. So we should give these names, right? Why don't we call L the length, and let's use W for width. Right, you can use X and Y or any letters you want, but in this case, L for length, W for width makes perfect sense, I think. Right. So the area then is just L times W. But L times W, they tell us what the area is, right? It's just this 117. Right? So L times W is 117. And that's an equation. The problem is, right, it's two variables. It's L and it's W. So trying to find either of these is going to be exceedingly difficult here. Luckily, they give us another clue. If you read the next statement, it says that the length is 4 yards longer than the width. So the length is not the same as the width. It's 4 yards longer. Right? Does this make sense? If the width is 10 yards, right, then the length would be 10 plus 4. It would be 14 yards. Now that's not the answer, of course, because, well, look what happens. If I multiply the length times the width, 10 times 14 is 140, which is not 117. So, yeah, so that's not the garden. All right, so again, let's not try to guess. Let's do this a little more systematically. For one thing, now that we know what L is in terms of W, right, I can replace this L here with W plus 4. Right? In other words, L is W plus 4, but then we multiply by W, and that gives us 117. Okay? So this is sometimes called a substitution, right? We're substituting for L the expression W plus 4. It's something you've probably seen earlier, right? Okay. So now we have this equation, W plus 4 times W equals 117. I just copied it down from here. Right? So now we just have to solve this equation for W. Right? And it is a quadratic equation. If we expand it out, we get W squared plus 4 times W equals 117. And although it's not in standard form, that's an easy fix. Just subtract the 117 from both sides. And now we get W squared plus 4W minus 117 equals 0. Now it's in standard form. Now to solve it, we just have to be able to factor it. And you can see this is another trinomial. The GCF is 1. So we're looking for two numbers whose product is negative 117 and whose sum is positive 4. So negative 117, let's try negative 1 and 117. That adds to 116, not 4. So that doesn't work. So 117 is not an it's not an even number, so we can't divide by 2, but we can divide by -3, and we get 39. That adds to 36, still not equal to 4. So we know we're not going to be able to divide by 4 or 5 or 6. What about 7? Nope. 8? Nope. Try 9. Yep. 9 times 13 is 117. So -9 times 13 is -117. And -9 plus 13 is +4. There's our match. So the two numbers are -9 and +13. Okay. Now we're almost done, right? Just set them equal to 0 and solve for W. Right? So W is either 9 or -13. Right? But does that even make sense, right? This is a garden. When you measure the length or the width, you're not going to get -13. Right? So just by the very nature of lengths and widths, these are positive numbers. We can ignore the negative here. Okay, so that leaves us with +9. Right? But +9 what? It's not feet, it's not inches, right? It's in yards here. Again, we know that because it says yards in the problem. Okay, so W, which is the width is 9 yards. But they also want the length. Find the length and the width. But remember, the length is just 4 yards longer. L is W plus 4. So L is W plus 4. W is 9. So 9 plus 4 is 13. Right? Not -13. We crossed that out. So L, which is the length of the garden is 13 yards. And that should answer the question. Find the length and width of the garden. The length is 13 yards, the width is 9 yards. And as a way to check, right, if I multiply the length times the width, 13 times 9, I get 117 square yards, which was exactly what the question said, that the area was 117 square yards, right? So it works. We know this is correct. Okay. Yeah, now again, why I crossed out the -13 is just because length and width are usually positive numbers. You know, some quantities can be negative, but not lengths, not widths, and certainly not area. Area is not negative, right? So whenever you do get a negative number for that, you can safely just ignore it in these problems here, right? Okay, let's try another one. Okay, next question. A rectangular poster has an area of 154 square inches. The poster's height is 3 inches longer than its width. Find the height and the width of this poster. Okay, so I'd start by just drawing a poster. So that's something like that, right? And we have the height and we have the width. Right? And then the area inside, 154 square inches. So we're looking for the width and the height of the poster, right? So let's let h be the height, and w is the width as before. Right? There's no length here. I mean, I guess we could call this the length instead of the width. Here they're calling it the width. Fair enough, right? So remember, area is just length times width, or in this case, the height times the width. So that has to be 154 square inches. That's in the problem. Right? And again, this equation here is not enough to be able to solve the problem. I mean, there's a lot of different ways you can multiply two numbers and get 154. But only one of them has this condition, right? The poster's height is 3 inches longer than its width. So the height is not the same as the width, it's 3 inches longer. Right? Not 3 times as long, 3 inches longer. Right? So if the width is 10 inches, then the height would be 3 inches longer. It would be 13 inches. Again, that's not the answer because 10 times 13 is not 154. So a bad guess on my part, but I'm just kind of illustrating, that the, oops, sorry, I didn't mean to cross out this equation here, just this part here, right? So yeah, h is w plus 3, right? But if h is w plus 3, then this h is also w plus 3. So I get the equation, w plus 3, which is h, right, times w equals 154. And if you expand this out, you get w squared plus 3w equals 154. So that's a quadratic equation, not quite in standard form, right? We have to take away the 154 from both sides. And if we do that, we get w squared plus 3w minus 154 equals 0. So it's in standard form, right? A is 1, B is 3, C is negative 154. So we're looking for the product. Oops, sorry, 154. Of two numbers is negative 154. And the sum has to be b, which in this case is 3. So what two numbers multiply to negative 154 and add to positive 3? Right. So it's obviously not going to be negative 1 and 154 because that adds to 153. It's not going to be negative 2 and 77 because that's 75. Yeah, just making sure. 154 divided by 3 is not divisible, or 4, or 5, or 6. 7 works, so we can do negative 7 times 22. But 22 minus 7 is 15. Still not equal to 3, so let's keep going. We're not divisible by 8 or 9 or 10. 11 works, so negative 11 times 14 is negative 154, and 14 minus 11 is 3, which is what we want. Okay, so when we factor, we're going to factor this as w minus 11 times w plus 14. Right, so you have to be careful here. You might jump to conclusions by saying, oh, it's 14, right? Because that's the positive number. We're going to ignore the negative here. But be careful because it's actually the opposite, right? When you set these equal to 0, you get positive 11, right? And, oops, I forgot to show this here. Negative 14. And so we don't want the negative, we want the positive, right? So W is 11. 11 what? Inches. These are in inches here. 11 inches. And we're looking for the height as well. Remember, the height is 3 inches longer than the width. So H is just W plus 3. And we know what W is. It's, oh, sorry, W plus 3. Right, W is 11. So 11 plus 3 is 14. So there we go, right? The height of the poster is 14 inches, and the width, right, is 11 inches. And that answers the question. Okay, so that's how this works. Again, just to summarize what we did here, right? First, make sure you declare your variables, right? Again, you don't have to use h and w. You can use x and y. But if you do that, you better make sure you say which is which, right? Because if you just write down, x is whatever, x is 12, y is 15 or whatever, and I don't know which one's which, then I can't give you credit for that. Right? So you actually have to specify, look, x is the width, right, and y is the height. Of course, you can easily just say the width is y and the height is x, but you have to say which is which, right? So don't get those mixed up. But yeah, even if it's obvious, like h for height and w for width, you should also write it down. Because believe it or not, some people like to use w for the height and h for the width, which makes no sense whatsoever. You'd be crazy to do that. Get all confused, right? But yeah, do declare your variables, right? Then just use the information in the statement. The area is 154, so that tells me that h times w is 154. Right? And then the second statement says the poster's height is 3 inches longer than the width. That tells me that h is w plus 3. Right? And when you do the substitution, you get the quadratic equation, put it in standard form, factor it, and then solve the equation. Set both factors equal to 0. Typically, one will be a positive number, one will be a negative number, and in most cases, you can ignore the negative number. And if there are certain cases where you're not going to ignore the negative number, we'll make that clear, right? So if you're looking for a positive or negative integer, then the negative 14 might come into play in some other applications, but not here, right? Okay, so these are rectangles. I hope that helps. Yep. Okay, so our next application has to do with right triangles. So a right triangle, it's a triangle, of course, that has a right angle. Right? Remember, a right angle is 90 degrees. And you know it's a right triangle if you can draw a little square on one of the angles, right? So that's a right triangle. And we're looking for the three sides here, right? When you take your trigonometry class or pre-calculus class, you're also going to be concerned with the other angles, these angles here. But not here. We're not worried about angles other than the 90-degree one, right? So we're looking for the three sides, and typically we'll just label them A, B, and C. So A, B, and C. And usually C is going to be the longest side. C is sometimes called the hypotenuse. And the two shorter sides, the A and the B, these are called legs. These are the legs of the triangle. So A is a leg, and B is a leg. Okay. And the relationship between A, B, and C is something that you must have seen by now. C squared is equal to A squared plus B squared, right? Or A squared plus B squared equals C squared. Let me write it that way usually. So this is the Pythagorean theorem for right triangles. So if you've never seen this before, well, here it is. And you should know it, right? So this is an equation that we're not going to give you. It's one that you should know. And the one mistake a lot of people make is say, well, if everything's squared, why can't I just, cancel the squares? And you end up with A plus B equals C. So why can't I do that? Because it's just plain wrong. It doesn't work. Right? You cannot cancel the squares like that. Right? It just doesn't work. What would work is if it was, say, a plus b, the whole thing squared, equals c squared. Now, you could just cancel the squares. But that's not what we have here, right? A plus b squared has nothing to do with a squared plus b squared. We talked about that when we were factoring, right? So, yeah, this is not what you want to do, right? So, for sure, a plus b does not equal c. That would be nice. It's just never true. Not for triangles, right? Okay, so let's take a look at a problem where we're going to need to use this Pythagorean theorem, right? This is the equation that we're going to be using. Okay, so here's the question. Sorry, this is example 5 for this video. If one leg of a right triangle is 5 feet and the hypotenuse is 1 foot longer than the other leg, find the length of the other leg. Okay, so I would start by just drawing a right triangle here. And you don't have to, but it helps to visualize. I know it's a little sloppy, but it doesn't have to be perfect. Okay, so one side is 5 feet. So let's say that that's this side here, right? So that's the length, right, of that leg. Now the hypotenuse is 1 foot longer than the other leg. And we want to find the length of that other leg. So here's the other leg. So why don't we just call that x, right? This will be x feet long. Okay, so how do we find x? Well, we know something about the hypotenuse, this being the hypotenuse here, right? It's only 1 foot longer. So whatever x is, just add 1 to it. So the hypotenuse is x plus 1 feet long. Got it? So, right, this is my A, B, and C. And we know the Pythagorean theorem, a squared plus b squared equals c squared. You can look it up, of course, but on a test, you should know it. So let's just replace a with x, right? And b with, well, 5, and c with x plus 1. Okay, so we just have to solve this equation now. We're solving for x, right? So we're looking for the other leg, x, right? This is the other leg. Because, right, we know the first one was 5 feet long. So that's not a mystery, right? That's given in the problem. One leg is 5 feet long. We're looking for the length of the other leg, right? Okay. So let's just solve this equation. And this looks tricky, right? X squared plus 5 squared. 5 times 5 is 25, right? Now, be careful of the right side, because a lot of people have a tendency to do x squared plus 1 squared, but that's wrong, right? You can't do that. You cannot distribute the square here, right? X plus 1 squared means what? It means x plus 1 times x plus 1. So in order to expand this out, you have to use FOIL. Right? So let's do FOIL. X times x is x squared. Then we get x times 1, which is just x, plus 1 times x, which is also x, plus 1 times 1, which is 1. Okay, so yep, you got to combine x plus x, and that gives you 2x plus 1. Okay, so here's our equation. And again, it's not in standard form. We want to get 0 on the right side here, or the left side. In fact, I'm going to switch these two sides, if that's okay with you. You don't have to, of course. Nothing wrong with doing that. Right. I hope you see that, right? I mean, if I write, a equals 7 or 7 equals a, yeah, it's the same thing, right? So, okay, we know that. All right, so now we want to get 0 on the right, right? So I got to subtract the x squared from both sides. And that just leaves us with 2x plus 1 equals 25. Oops, that's supposed to be a 5. And now just take away the 25 from both sides. And we get 2x minus 24 equals 0. But notice something weird about this. We canceled the x squares, right? There is no x squared anymore. So it turns out this is not even a quadratic equation. This is a linear equation. And you should be able to solve that in your sleep. That's how easy this is. So it turns out we shouldn't have subtracted the 25. We should have subtracted the 1. But okay, a little late now. Let's add the 24 to both sides. Right? And we can do that because, remember, there's no x squared anymore. So all we need to do now is just divide by 2. 24 divided by 2 is 12. And that's the answer. That's the length of x, right? That's the length of the other leg. So the length of the other leg, forgive the sloppiness here, is 12 feet. Don't forget to put the units, 12 feet long. Right. And that's it. And, the hypotenuse, of course, would be x plus 1. 12 plus 1 would be 13 feet. But they didn't ask for that. They could, of course, ask for the hypotenuse as well. In that case, your answer would be 13 feet. But the length of the other leg, right, is just 12 feet. Right? And you can check. You can plug it back into the original equation way up here. See if it works. All right. So that's one example. Let's try another one. Okay, a right triangle has one leg 4 meters shorter than the hypotenuse. The other leg is 8 meters shorter than the hypotenuse. Find the lengths of all 3 sides. Okay, so again, we're talking about a right triangle. I guess I'll draw it this way. Again, these are supposed to be straight here. And I'll just label it A, B, and C as usual. At least for now. Okay, so how are we going to solve this, right? We have a right triangle, one leg. Let's say A is one leg. It's 4 meters shorter than the hypotenuse. So the hypotenuse is C, right? Let's say, C is, 15. That's just a guess, right? What would 4 meters shorter than that be? 15 minus 4 would be 11, right? So when we say it's 4 meters shorter, we just have to subtract 4. Right? So A is really just C minus 4. Okay, the other leg is B, and B is 8 meters shorter than the hypotenuse. So B then, right, is C minus 8, the hypotenuse minus 8. Okay, so remember for a right triangle, right, A squared plus B squared is equal to C squared. Right, and this one's a little trickier because we don't know what C is, and we don't know what A is. However, we can replace A with C minus 4. We still have to square it, but that's what A is, right? Plus B squared. Now B is also C minus 8, so I can change B to C minus 8. And I can leave the C squared on the right alone. Okay. Right? So because, right, C is effectively is our variable here, right? We're looking for C. Once we know C, we can find A by subtracting 4, and we can find B by subtracting 8. Okay. The point is, right, this is our equation. It only has one variable now. It's just C. So we could have used X or Y or whatever, but we're using C here, right? So now we just have to solve this equation, right? So let's solve C minus 4 squared plus C minus 8 squared is equal to C squared. Okay, first thing to note is that it's not in standard form, right? It doesn't equal 0, but we can subtract C squared. Let's do that on the next stage here. We can subtract the C squared from both sides. Okay, and now it equals 0. Right. Next thing we have to do is expand this out, right? C minus 4 times C minus 4, right, is C minus 4 squared. Same thing with C minus 8 times C minus 8. And then we still have the minus C squared, right? So if you FOIL this out, you're going to get C squared minus 8C plus 16. And if you FOIL this out, you're going to get C squared minus 16C plus 64. And then don't forget the minus C squared here. And that still equals 0. Okay, right, so now we just combine like terms. We have C squared plus C squared, that's 2C squared, minus 1C squared. Right? Or if you like, C squared minus C squared is 0, but we still have this C squared on the left. Okay. What else do we have? We have negative 8 times C minus 16 times C, and that adds up to negative 24 times C. And finally, we have 16 plus 64 is 80. Right. And that takes care of everything, right? That's still equal to 0. Okay, so this is looking good. This is in standard form. So at this point, all we need to do is factor this. What two numbers have a product of 80 and a sum of negative 24? Okay, so we've been through this many times, right? Here, because the sum is negative, they both have to add up to a negative. So it's not negative 1 and negative 80. It's negative 81. Right? It's not negative 2 and negative 40. That's negative 42. It's not negative 4 and negative 20. That's negative 24. Oh, my bad. That's actually correct. Negative 24, right? Right. I skipped negative 3 because I knew 80 is not divisible by negative 3. So yeah, let's just make sure, because it's a little sloppy here. 80 is negative 4 times negative 20. And negative 4 plus negative 20 is indeed negative 24. Okay, so the two numbers are negative 4 and negative 20. All right, now let's just set them equal to 0. If C minus 4 is 0, then C has to be equal to 4. The other possibility is C minus 20 equals 0. So when you add 20 to both sides, you get C is equal to 20. Right? Now notice they're both positive, so it's not like we can cross off anything yet. So are there two possible answers here, right? Is C equal to 4? Is that a possibility here? Okay, so remember, C is the longest side. C is the hypotenuse. So if the hypotenuse was 4 meters in this case, use m for meters, what would the other sides be? Well, A would be c minus 4. 4 minus 4 would be 0. Well, it can't be 0. If it's 0, then there's no triangle, right? Even worse, the other side would be c minus 8, right? That would be 4 minus 8 would be negative 4. You can't have a negative length, right? So I think we can rule out c equals 4. Even though, 4 is a perfectly good number, it's a positive number, it could be the length, but then the other two sides would either be 0 or negative, and that's nonsense, right? So I think we can cross out c equals 4 for that reason. What about c equals 20? So since I messed up the previous triangle here, let me just draw it again down here. Right? So let's suppose c is 20. Remember, a was c minus 4. But if c is 20, 20 minus 4 would be 16, and that's still a good number. That's positive, right? B was c minus 8. So 20 minus 8 is 12, and 12 is a perfectly good length as well. So I think that's it, right? The three sides are 16 meters for one leg, 12 meters for the other leg, and the hypotenuse is 20 meters. Okay. So, yep, the three sides are, you can go in order here, 12 meters, 16 meters, and 20 meters. So either way. Right. And you can double check by plugging it back into the original equation here. Or at this point, you can even do this, right? So what did I say? A is 12. No, A is 16, B is 12, C is 20. So as a check, let's do 16 squared plus 12 squared. Is that really equal to 20 squared? So 16 times 16 is 256. 12 times 12 is 144. And 256 plus 144, I think, is 400. But 20 times 20, right, is also 400. So 400 equals 400. I think that works. Right? And we could have just checked the C here, but it's fine. So, yep, the three lengths are 12, 16, and 20. Don't forget the meters, because it's not feet, it's not inches, it's not yards. Here it's meters. All right, so this one's a little bit harder, this right triangle problem. But you just go through, read the question carefully, write down the equation, solve the equation, and that should give you the solutions. Okay. Okay, so now we come to the last type of problem in this section, and those are projectiles, right? Things that you're dropping or throwing. So here's the question, right? We have a rock is dropped from the top of a 144-foot tall building. It's abbreviation for feet. Its height, t seconds after being released, is given by h, which is the height, equals 144 minus 16 times t squared. How long does it take for the rock to fall to the ground? Okay, so that's the question. And if it helps, just draw a picture here. So we have a building, right? And we know the height of the building is 144 feet. All right, so someone has measured the height of the building, right? And someone dropped a rock from the top of the building, and what happens? Well, it falls down, right? And eventually it just hits the ground. Okay, so how long did it take to go from the time that you dropped it until it reaches the ground? It's a very reasonable question, right? I mean, in some sense, it's kind of a physics question, but it's, at this point, it's a math question, right? Because we know the relationship between the time, t, right? T is the time, and the height, h. H is the height. And it's just given by this equation. Okay? And that's given in the problem. You don't have to know this, right? If you want to know where this equation comes from, well, then you have to take a course in physics. So I'm not going to explain this equation because this is not a course in physics, right? Right. This is, in fact, given to us, right? So, so here's the question, right? We're looking for how long it takes for the rock to reach the ground, right? So how long is how much time? Right? So we need to find the time, which in this case is t. So what is t in this case, right? T is how long it takes to reach the ground. Okay. So remember, we're starting at the top of the building, right up here at the top, which is 144 feet off the ground. So when the rock falls to the ground, how high is the rock above the ground? Right. So where's the ground? Right. This is ground level. The ground is 0, right? If you're on the ground, you are 0 feet above the ground. If you're at the top of the building, right, you're at 144 feet above the ground. Okay? So here's the key. When you're on the ground, the height is 0. So we're looking for the time when h is 0, right, 0 feet. So here's the equation, right? H is equal to 144 minus 16t squared. But if h is 0, then you're on the ground. And now we can solve this equation for t. Okay. So there's the equation. Now, if it looks backwards to you, that's because it probably is. The 0 should be on the right side, right? So we can always just switch them around. We did that once before. Right? And you might think it still looks backwards. And if that's the case, then you can switch the order of the terms. This is negative 16t squared plus 144 equals 0. That's okay too. And notice that it's just two terms, right? So we're not going to use the AC method here because there's only the two terms. How do we factor this over here? Okay, so hopefully you remember the first thing you look for is the GCF. And the GCF in this case is negative 16. So we can factor out the negative 16, leaving us with t squared minus, right, because it's a negative times a negative is positive 144. So 144 divided by negative 16 is negative 9. So minus 9. Okay. And the t squared minus 9, that should look familiar. That's just the difference of two perfect squares, 9 being 3 squared. So a squared minus b squared is a minus b times a plus b. And it's still equal to 0. Now we just set each factor equal to 0, right? T minus 3 equals 0, or t plus 3 equals 0. So when you solve t minus 3 equals 0, you add the 3 to both sides, and that gives us t equals positive 3. For the other equation, you subtract 3 from both sides, giving us t equals negative 3. Okay, so which one makes sense here, right? What does t equals negative 3 seconds mean? Well, it was 3 seconds before we dropped it. We don't care what happened before we dropped it, right? We care what happened after we dropped it. So I think we can ignore the negative time. Negative time just means you're going backwards in time. Since we want to go forwards, I think the 3 seconds makes the most sense here. So how long did it take for the rock to hit the ground? It took 3 seconds. Right? So t is equal to 3 seconds. You can abbreviate s for seconds or just write out 3 seconds. Right? So yeah, if you can do this experiment, right? Go up to a building that's exactly 144 feet tall. Take a rock, drop it, and then, have a stopwatch, right? Start the clock when you drop it, and then stop it when it hits the ground, and you'll see it's about 3 seconds. It may not be exactly 3 seconds, but it's pretty close. Right? And there's several reasons that it's not exactly 3 seconds, but let's not get into that. That's more physics, right? Okay. If you're wondering, wait a minute, what about the negative 16? That's a factor. Why didn't I set that equal to 0? Well, maybe I should have, but solve this equation. Negative 16 equals 0. What does that mean? Right? There's no t. There's no variable here. There's no x, there's no y, there's no t. And I don't know about you, but negative 16 certainly does not equal 0. So the reason why I didn't set negative 16 equal to 0 is because that simply has no solution here. Right? The negative 16 is just the coefficient in front. We could have divided by negative 16. Right? We really didn't have to worry about that. Right? We could have divided by the negative 16 in this step here. And that would just give you t squared minus 9 equals 0. And then that would give you the positive 3 and negative 3. Right. Okay. So anyways, yep, 3 seconds. Don't forget the s for seconds. And that's the solution, right? So yeah, it roughly takes 3 seconds for an object to fall 144 feet. Okay, so that's one type of projectile problem. Okay, last question. The height of a ball that's thrown from the height, the height of 80 meters with a speed of 20 meters per second is given by the equation, right? So h for height is negative 10 t squared plus 20t plus 80. Okay, so this is given, right? Find the time it takes for the ball to reach the ground. Okay, so when you see the word ground, you remember from the last problem that that means 0 meters in this case, right? So we're not doing feet anymore, we're doing meters. We're still doing seconds though, right? It's 20 meters per second, so t is still in seconds. Right. So, yeah, so find the time, right? So we're looking for t. Find t so that the height is 0 when it's on the ground, right? The height is 0. So, yep, we just have to solve this equation. Negative 10 t squared plus 20 times t plus 80 equals 0. And again, the nice thing is that it's already in standard form, right, because it equals 0. And it is quadratic. It is t squared, right? So GCF. The GCF is just the negative 10, right? So why don't we factor out the negative 10? Right. In fact, you can also divide by it. Or just ignore it. 0 divided by negative 10 is just 0. So you're left with t squared minus 2t minus 8 equals 0. So this is a very, very standard, typical quadratic equation. And to factor it, we're just looking for two numbers whose product is negative 8 and whose sum is negative 2. Okay. So it's not going to be negative 8 and positive 1 because that adds to negative 7. It's got to be negative 4 and positive 2. Right? Negative 4 plus 2 is negative 2, and negative 4 times 2 is negative 8. So, yeah. So at this stage, hopefully it's just that obvious, right? So set them both equal to 0. And we get t is equal to 4, or t is negative 2. And for the same reason as last time, I think we can ignore the negative 2. So the answer should be t equals 4. In this case, find the time that it takes for the ball to reach the ground, right? So that time is 4 seconds. And we're done. Of course, you can check, plug in 4 into the original equation. And I haven't been doing that, but it's always a good idea. So I think I'll do that. And then we'll call it a day here, right? So negative 10 times 4 squared plus 20 times 4 plus 80. Does that really equal 0? All right, 4 squared is 16, so this is negative 10 times 16 plus 20 times 4 plus 80. So that's negative 160 plus 80 plus 80. And negative 160 plus 80 is just negative 80. And negative 80 plus 80 is indeed 0. 0 equals 0. So I think we have it, right? We know the answer has to be 4 seconds because it fits the equation, right? It solves the equation. Okay, so that's how this goes. Remember, the first 2 problems were just number puzzles. The second 2 were rectangles. And then we did 2 triangles, and now we're doing projectiles or things that you're throwing or dropping, either way. And for these problems, again, they will give you the equation. You don't have to figure out where this comes from, right? Here, they gave us this equation here. Right? Where that comes from doesn't matter. It's a physics question, but we're not going to answer that here, right? Now, the equal 0 part, that you had to figure out because we want it to be on the ground, and the ground is level 0, right? 0 meters above the ground. All right, so I hope this helps. And, I know these word problems are not easy at first, but it's just these 4 types of problems, and I did 2 of each kind. Hopefully that's enough. And that should do it. So best of luck.